Okay, this is Algebra 1, Chapter 2.9. We're going to talk about weighted averages. For the most part, when we say weighted averages, we're going to do mixture problems. But weighted average, guys, is of a set of data, is the sum of the product of a number of units and the value per unit divided by the sum of the number of units. What? Okay, so basically it says product is a sum of the product of a number and its value. So what that means is how many times you're using it times its value, added up, divided by the total number of items that you are using. Because think about what's average. Add them all up and divide by the number being used, right? That's what average is. But here's the thing. Weighted averages, guys, are when you start to put things together that are not of the same amount. Hence, we have an example here. It's a lot of words, but I thought it was good to have this whole entire example. Basically, it comes down to 2 school classes in a day. One of them has 20 students and the other one has 30 students. And then you can see the grades from all of those kids in the class. Okay? Then we go below to the paragraph and they start explaining some information about this. We start to explain that the morning class average is 80. And the class average of the afternoon class is 90. So does that mean I can just take 80 plus 90 and divide by 2, which would be 85? That should be the average of the 2 classes, right? Unfortunately, that's not the average, the true average. The true average, guys, of the classes, if I wanted to know how the morning and afternoon class did as together, it would mean I would have to take all of the scores in the first class and all the scores in the second class and add them all together and divide by that total. Look at this. Are there the same amount of students in the morning as in the afternoon? No. So which class do you think has a bigger effect on the score, on an average? The one with more numbers, right? The one with more numbers will have a bigger draw on that number. So 85 is not the answer. It's actually above 85. And so that's what this word is saying. It says that this does not account for the difference of the number of students in each class. It's 20 verse 30. And it says, hence the value 85 does not reflect the average student grade in the whole thing. The average student grade can be attained by averaging all of the grades. So guess what? If I took all of their scores and add them all up, I get 4,300. There were 50 kids. That's 86. The average, the true average for both classes together would be an 86. You can do that, but what happens if I don't give you all of those scores? Here's the cool thing. If I only gave you the fact that there's 20 students in one class that had an average of 80, if there's only 30 students that had an average of 90, whoops, then you would have to use the weighted averages down here. That says, that's really small, I see that on the screen. All I do is I take the amount of students, or how many times am I using the average of 80? 20 times, right? And if I multiply 20 times 80, guess what number I will get? What number will I get when I take 20 times 80? I'm going to get the value, guys, of taking all of their numbers and doing what? Adding them all up. I'll have the total for that class. And if so basically, 80 times 20 gives me the total for the first class, and 30 times 90 will give me the total for the second class. And if I add all of them together and divide that by 20 plus 30, aka the total number of students, I should get the same value of 86. I need to figure out the value of the average in one class, add it to the value of the average in the other class, and divide it by the number of students total. That's how weighted averages work. You just don't add up the averages that are there already. You have to realize that something that is higher value or has more of it has a bigger weight on the average overall. Okay? The first problem that we'll come across is a mixture problem, which the next 5 or 6 of them will be. It says that a tea company sells blended tea for $25 a pound. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Now, let's think of this. The blackberry tea is $25 per pound. That is made up of 2 other things: blackberries and black tea. Right? Kind of makes sense, blackberry tea. Guess what? Blackberries are relatively cheap at $10 a pound, right, for this particular problem, compared to the final result. But tea costs more. The black tea costs more at $35. So some combination of adding blackberries, which are cheaper, and the tea, which is more, start to move towards each other. Can you guys see that? Because 25 is between the 2 ends of prices. The final price of the blended tea will reflect the total cost of blackberries in it and the total cost of black tea in it together. Does that make sense? And that's what we need to find today. So, we go about doing this, guys. I find the easiest way to do this is to make a chart. I am going to make a chart. This chart looks something like this, where all the way over here, I know that I'm going to put my labels of things that I am putting into the chart, or into the chart, sorry. Okay? Now, there's a few rules for this chart. The top 2 rows of this are the ones you're putting together. The last row is always the thing you're making. So we're making blackberry tea, right? We're putting blackberries in, and we're putting tea in. So blackberries is one thing going in, tea is another one going in. That creates blackberry tea. Everybody okay with that? 2 things going in, the thing coming out. Now, there's a box on top. That box now needs to be subdivided into the units or the labels of certain things. There's a couple things it tells us in the problem above. We have a cost part to all of these, and we have poundage. The more pounds, the more cost it will be. So, I'm going to start splitting this box up. The first box, let's put cost. How much does it cost for blackberries? Start filling it in. What's it cost for the blackberries? $10.50. How much is it for the tea? $35. And black tea is $25. Is everybody okay with that? The connection between all of these or the other thing about it is that you got poundage. You got a certain amount of pounds going in. Do we know any of these pounds going in? How many pounds of blackberries we have? 5. Actually, can I fix something real quick? What if I took the cost out and put price? I don't know. Unit price? I don't want to use cost because I want to say cost over here. What does it cost for the total cost, right? The more pounds I buy, the more it costs. So let's talk about unit price. That's price per pound. So wait a minute. Just looking at the blackberries there. If blackberries cost $10.50 a pound and I use 5 pounds, how much money do I spend on blackberries? Fritz? How much? I don't think it's me $70. That's a little too much. $50. Oh, 52. 50 cents. So how did you guys get that, guys? We multiplied these two numbers together. Your unit price, how much it is a pound, times how many pounds. Pounds will cancel because it's dollars per pound. Pounds on the bottom. Times 5. $52.50. Okay. Guys, the question overall is asking how many pounds of black tea. So we don't know that, do we? Do we know how much tea is in there? No. So guess what I'm going to do? I'm going to call it X. So how much money would it cost me for the tea? If it was 1 pound of tea, how much would it cost? 1 pound of tea. How much it cost? $35. 2 pounds of tea. And you're doing that because you're multiplying, right? However many pounds times 35. But you don't know X. So we got to leave it as X. So it would be 35 times X. Or 35X. Can everybody see that? Now, we don't know how many pounds of black tea are going into this mixture, but we know there's 5 pounds of blackberries. So how many pounds of blackberry tea will I end up with? Say it again. At least 5. 5 what? Not 5X. Okay, let's just say there was 1 pound of tea going in. How many pounds total are at the end? 6. If there was 2 pounds of tea, there would be 7. Wait, how are you guys getting that? What are we doing? What are you doing with X and 5? Aaron, adding them. But do you know what X is? No. So guess what? I have to leave X as X. The total poundage would be X plus 5, right? Now, if you know the poundage is X plus 5 pounds, and you know it costs 25 pounds, how much money does it cost? Unit price times your poundage, right? So this one should be 25 times X plus 5. And now you're thinking, okay, it's great, Mr. Contract. We have this table filled out, but I still don't have X. I don't have the amount of tea that's going into this. You're right. But what if I told you there's a way now? If I told you you put $10 worth of blackberries in it, and you put $35 worth of tea into it, how much would the blackberry tea cost you? $45. How did you figure that out? You add their costs individually, which should be the same as the total cost of the tea. Can you guys realize that? The total cost of something is the individual costs added up. Guess what? $52.50 was the individual cost of the blackberries when I put 5 pounds in. Tea, we don't know how many pounds, but if I knew exactly how many pounds of tea it would be 35x. So that is my cost of the tea. And here's the cool thing. Down here, we said if there was X pounds of tea plus 5 pounds of there, I would have a total poundage of X plus 5. And whatever that is, I multiply it by 25, it will be the total cost of the blackberry tea. Here's my total cost. Right there. It's made up of these two. So guess what I can do? I can take the top 2 columns, or rows, and add them and set them equal to the bottom. So what you get is 52.5 plus 35x equals 25x plus 5. Can you solve that equation? And if you solve for x, you will find what? The number of pounds of blackberry tea, or the black tea, sorry. And you could then eventually find how much blackberry tea was created. Once you know x, you got the key, you got the rest of it. So let's do that together. I'm guessing the left-hand side is done, right, for now? So 52.50, we'll copy, paste it. What should I do with that 25, guys? Should I do with the 25, Logan? Distribute. 25x plus what? 125? Now it looks a lot like our problems. Ooh, it has decimals in there. We can deal with that later. Variables on both sides. Which one am I going to move? Why? Kathy? Yeah, we'll move the 25x. It's smaller. So subtract 25x from both sides to end up with 10x. But since I'm getting the x's to the left side, I might as well get rid of the number on the left too. Can I do that at one step here, guys? You guys be okay with me subtracting the 52.50? Because what's 125 minus 52.50? $72.50. And then to get x by itself, I will divide by 10. So x is going to equal 7.25 what? Pounds of black tea. How many pounds of black tea should be added? Well, you'll have to add 7.25 pounds of black tea. Now wait a minute. Let's think about this problem. The prices, guys, going in are $10.50 and $35. The final price is $25. Let's think about this. Is 25 closer to 35 or is it closer to 10.50? It's closer to the 35. So, according to what we talked about on the last slide, which one should we use more of? If it's closer to the 35, we need to use more 35. Hence, we're using 7.25 pounds. Right? And that's why it works. It works. It's pretty cool. How many pounds of premium coffee beans should be mixed with 2 pounds of supreme coffee to make a blended coffee? If the premium coffee is $9.50 a pound, the supreme coffee is $11.75 a pound, and the blended coffee sells for $10 a pound. I want you guys to see if you guys can set up a table first. So we got to build a table. Does your table look something like this? And we know we're putting two things together to create a thing at the end. Okay, so what are we putting in? Premium. We're also adding supreme to make a blended coffee. Okay, what are some things we know about these coffees? We know some unit prices and we know some poundage. So therefore, it's like the last problem where you're going to need 3 columns, where you're going to have your unit cost or price. You will have your poundage and total cost. Okay? So, what's the unit prices of the premium? $9.50. Okay. Supreme? $11.75. And our blended, what happens to be evened out at $10 a pound. Do we know any other information? Because we need to at least know something. One more piece of information is all we need. 2 pounds of supreme. Ooh, down here. We know this one. And if I know, okay, so everybody have that? If I have 2 pounds of supreme, how much is this thing going to cost me? How much is the supreme coffee portion of it going to cost me? Is it 24 something? 23.50. It's going to cost me $23.50. $11.75 times the 2 pounds I'm using. And it says, how many pounds of premium should be mixed? So that means if I go up to premium, I don't know. I just don't know how much is going to be used. But I do know the cost then as soon as I find out X. What is it going to be? What's the cost, total cost of the premium coffee then if I don't know X? Or if I say it's X? 9.5X. How many total pounds are going to be in this coffee blend? It's going to be 2 plus X or X plus 2. Thing is, if I have X pounds of premium plus 2 pounds of supreme, it's going to have to be an X plus 2. Then, what is the price then of the blended coffee? 10 times X plus 2. And the cool thing about this is the top 2 prices or costs will equal the cost of the blended coffee. So, what can we do? We can say 9.5x plus 23.50 equals 10 times x plus 2. And solve it there. Again, I think the left-hand side's good to go. We've got to do what with the right-hand side? No, we're not going to get the x out of there yet. We're going to get the 10 taken care of. Can I drop the 0 at the end of the 0.50? Yeah. That just complicates things sometimes. So this is 10x plus 20. And Now, which one's actually smaller, guys? Which one do I want to get rid of? The 9.5x. So I subtract 9.5x from both sides. And while I'm at it, since I'm bringing everything to the right side, or the x's to the right, I want to get the 20 to the... So I will subtract 20 as well from both sides. So 0.5x equals 3.5. How do I get rid of a half? There's two ways. I could divide by a half or multiply by a 2. And what's 2 times 3.5? So guess what? You have 7 pounds of premium coffee. And that's what it's asking, right? What if it asked you how many pounds of blended coffee are created? What would you say? How many total pounds of coffee will be put all together? Real. 9. 7 plus 2, guys. Put it here. Put X in. Okay, guys, wait a minute. Let's look at these last two tables. These last two tables, something has been happening every time. What seems to be happening as I go across the table to get here? What are you doing? Always. What do you do across? What's going on? Right there. Multiplication. To solve for the bottom boxes, what seems to happen with the top two to get to this one? Add them. When you move down the boxes, you add. When you're going across the boxes, you multiply. Guess what? It happens every time. Let me say that again. It happens every time. Homework for day 1 is on page 135, 1, 6, and 7. Have a great day.